Hi everyone, my name is Ryan and today my team and I will be presenting about our vaccine management system for information systems development methodologies, assignment 1. First, I will take you through the problem topic, define the problem, identify key stakeholders, and outline the objectives of the project. Jacob will then take you through our vaccine management system prototype, explaining the logic behind its operations and going through some use case diagrams. Jack is up next, taking you through the agile development methodology we used and practices we used to develop our system, along with presenting some of our class diagrams and flow diagrams. Lastly, Jeremy will discuss the advantages and disadvantages if the system succeeds or fails and conclude the presentation. So let's get into the problem topic. The crux of the problem topic is the Chief Health Officer of the State Health Department has hired my team to develop a vaccine management system that supports logistics for the vaccine rollout. Our core takeaways for the problem definition are: the vaccine management system, or VMS for short, should include a central distribution center and handle multiple logistic issues, including distribution of vaccine supplies, prevention of over or understocking, and monitoring the vaccine stock of various vaccination centres. The system also needs to be able to allocate vaccination appointments for eligible citizens that request an appointment. So moving on to our stakeholders now, it is evident with the problem topic that it's quite large in scope. And as soon as the problem topic mentions the vaccines and health department, we immediately get a range of direct stakeholders with stakes in the system. These stakeholders include the general public, doctors and nurses or healthcare workers, our employer, the Chief Technology Officer, and employees in the vaccine management system itself. Here are some of the key point of view or how might we statements that we used to develop and evolve our problem definition. For the general public stakeholder, how might we efficiently vaccinate the general public without compromising safety or wasting vaccines? And how might we improve and streamline the process in which citizens are able to register for appointments? And for the healthcare workers stakeholder, how might we balance efficiently vaccinating the general public, but meanwhile not compromising on the safety standards we have in place for healthcare workers? Lastly, I'll cover the objectives of the project. Taking into consideration the problem definition of the topic and our understanding of the stakeholders through our empathy and journey maps, POV and how might we statements, our team has defined the objectives of the project as follows. Firstly, the vaccination management system will allocate and confirm appointment details accurately and efficiently. Secondly, the vaccine management system will use current stock data at vaccination centres to accurately and without error meet vaccination demands with timely vaccination deliveries. And finally, the vaccine management system will prevent any and all wastage of vaccines, over or understocking, and any breaches of safety standards. I'll now hand over to Jacob, who will take you through our vaccine management system prototype. Thanks.
Ideation is the foundational and experimental phase of the project. It usually consists of a sample of a product, in this case the Vaccine Management System or VMS, and gives an idea of how it will operate and interact with the user. To help create and design the sample, we have collected user requirements and organized it into a user story format. This framework allows us to think from the perspective of our stakeholders and will also assist us to find out what is required in our system for our users. We document these system requirements so that we know what is important to include in our system. Then we may go over these requirements and see what needs to be prioritized, estimate how long it would take, and how much it will cost to create them. Moreover, we then created a use case diagram to further the development process. This has helped us map out how our users and the system will interact. It can indicate to us if there could potentially be something missing within our system or think about a better way to improve on a specific operation that may lead us to betterment the interactions. For our VMS, it greatly helped to pinpoint what stakeholders are vital within the vaccination process. It clearly defines what each stakeholder must do within the system and what other stakeholders may have to do or may have to interact with to be able to do their job. This basically, for example, could be the state health minister has to interact with the delivery workers or the vaccine company to to order the amount of vaccines needed. And then the delivery worker then has to carry that out and send it to the healthcare worker uh, or to the storage facilities. Anyhow, furthermore, it can highlight that what we may be missing in the system. For example, the state health minister will order the vaccines, but while creating the user case diagram, we did not yet include a chain to deliver these vaccines to our facilities, so we promptly added that missing link.
Hello, my name is Yusei Wu, and for my section, I'll be discussing the prototyping stage of a vaccine management system. The purpose of the prototype is to highlight the tasks and processes that contribute to making the first version of the system. And secondly, it's to visualize how each element of the system interacts with each other. And finally, to describe the attributes, operations, and relationships that form the system. So you can see on the screen now, there's a class diagram that visually communicates the different entities that exist within the system. So the classes, we have patient, booking, distribution center, vaccination center, and vaccines. Each entity serves a purpose within the vaccine management system. For example, patient refers to a member of the public who requires the vaccine. The patient then makes an appointment via booking. The patient goes to their vaccination center and receives vaccine, and the distribution center is responsible for delivering and stocking up the vaccine center when there's a shortage. As you can see, for each class, there are many attributes related to them. The patient, for example, will have the attributes first and last names, date of birth, email address, home address, and phone number. Personal details required to make a booking. For each patient's appointment, there's the time and date attribute that for them, which for the booking, which is recorded, as well as the location of where the vaccination takes place. For each vaccination center, a unique ID is given to each center across Australia for easy identification within the vaccine management system. Each entity has various operations that showcase the actions that each entity performs within the system. You can see under each class here, which is here. A patient, for example, will have their appointment details, such as name and address when they have finished making the booking. The system will confirm the appointment and record it within the database. And for a vaccination center, its operations are to administer vaccine and to update the stock count within the storage unit to ensure there are no shortages. As for each class, there are unique relationships assigned between each entity. For example, take a look between the relationship between patient and booking. As you can see, it is a one-to-one relationship. It indicates that a patient can only be able to make one booking as they only require one dose of vaccine, and a booking can only be attributed to one patient. And for the relationship between a vaccination center and vaccines, we can see that it is a one-to-many relationship, indicating that a vaccine can be distributed to many vaccination centers, while each center can only have one type of vaccine. And finally, we have the activity diagrams, which help visualize operations between each class entity. They help highlight the flow of activity and the decisions that lead to each outcome. A visual representation of the flow of activities makes it clear what tasks and processes are required to fulfill the activity. For the activity diagram on screen, for example, it demonstrates the activities that takes place when a user first makes a booking. The user first choose their booking date and time. The system checks whether the vaccination center have any spare time slots. So, and if there are spare time slots, the activity will move forward, and the user will be given a ticket to confirm their booking. The system checks the storage units of the center and determine if there are insufficient vaccines for all the patients, and And then from that, you make a decision from that analysis. Now, Jeremy will talk about the advantages and effects of the system, as well as provide the consequences of failure. Thank you.
So such an important system will have a massive impact on launch, and the consequences of that impact will vary and depend greatly on whether the system is successful or not. In case of the success in deployment of new EMS, we can expect a major slowdown or complete elimination of COVID-19 spread, which in turn will allow to speed up countries' economic recovery and getting things back to normal. In addition to that, we will help us gain positive experience in dealing and managing situation with global pandemic for the future. A successful deployment of VMS system will also increase public's trust in government and government's pandemic handling. It will lead to general public are more obedient to government advices for the program and COVID safety measures, which is very important toward the project goal. This will also allow the government to keep track and monitor success and impact the new system has on situation with the virus in the state. However, in case of failing in case of a failure with the system's deployment, there are quite significant risk and impact that might occur. Firstly, financial loss possible due to money spent on the system development not returning sufficiently, or due to unusable vaccine since it might get overstocked, improper storage, or expired. The waste of spending will make taxpayer lose confidence in government as well as general public. This will also certain break or damage public's trust in government's effort and the health system, and in turn fail to stop the outbreak of COVID-19. This will cost us reputation and overall will cause us fail to deliver the vaccination project and therefore slow down the economic recovery. In conclusion, through this presentation we have carried out the stakeholders and their requirements by utilizing use case diagram and documentation them into user stories. In addition, by using different sort of diagrams can assist us identify the key problem that system need to solve. Also, I have go through the advantages if the system successfully deployed and consequences if the system will fail. Follow the agile methodology in development path should allow us avoid failing the VMS development. Thank you for your attention. Hope you understand the operation and importance of VMS rollout.